Alrighty, in this problem we have a convex mirror, and we know that the focus point is 8 centimeters away. We're told that the distance out from the mirror, or d naught, right? The distance away from the mirror that our object resides is 16 centimeters. And we're told that the image or the object that is going to project an image onto the mirror is up 3 centimeters from that point. Okay, so let's draw. We need to show a couple things here. We need to show virtuality so that the image is going to be a virtual one, and to do so using a ray tracing diagram. If f is 8 centimeters, which we defined here, what's the distance that image is away? And then what's the image's magnification? Okay, so how large, how much scaled up is that image? So that's the three things that we're trying to find today. Let's go ahead and find them. So to show virtuality, what we need to do is draw a ray tracing diagram. So what we do, draw a projection, maybe parallel. It's going to hit the mirror and it's going to bounce off going this way. Okay, so that's going to be the first one. Let me grab another color of chalk so we don't get confused here. Maybe even 3 pieces to really solidify. So we have one that went parallel and it shot off into space that way. Now let's draw one hitting the very center of the mirror. Okay, and we know that's going to go right through the focus point on our side here. So hopefully you can see the two rays, the reflected rays are going in opposite directions. They're not going to intersect a common point. And if you drew an infinite number of rays projecting, we're going to see that they're not going to intersect on the real side of the mirror, right? It's going to be on the other side of the mirror, which we'll see. So hopefully you can follow this. It's pretty cool. It's saying that, okay, the image or the rays aren't going to cross at one point. So at that specific point in our object, it's not going to have a real portion of the image. And in fact, to see where the image goes, we need to extend the rays backwards. It's a really interesting way to think about this and where it's going to show up. If we just extend the rays like this, we're going to see they bisect a common point. And in fact, oh, sorry, I unplugged my computer here. Let me plug that back in so it doesn't die. It's going to bisect this point here. And in fact, that is where the image is going to show up. It's going to be a virtual image. That's what a virtual image is, when it's behind the mirror, when the projected image is behind it. Okay? And that is showing virtuality, that we did that. So check that one off, right? But now we need to understand, okay, if the focus point is 8 centimeters, so the focus point would be here, or I guess the focus point would really be here, okay? Where's that image going to show up? Where is that image? Right there is where it's going to be, but let's show it. Let's show that it would be right here. Or I guess the focus point wouldn't be here, it'd be somewhere else. The focus point, I guess, we want to refer to being right there. So find df. Okay, how do we do that? Well, we know this formula to be true, hopefully at this point. 1 over f. So this formula relates the distance of the object from the mirror to the object, or the distance to the virtual image, to 1 over the focus point. So all we have to do here is say, okay, our initial distance was 16 centimeters. The distance of the virtual image, we don't know. That's what we want to find out. And the virtual portion of this, or where is the focal point? Well, that's 8 centimeters, but in this case, notice the rays are converging to a point behind the mirror, so the focal point is really -8 centimeters. Now what we have to do to find where the virtual image is solve this problem. Well, 1 over df is going to be equal, in this case, to 1 over -8 minus 1 over 16. And when we do that, we find it to be -3 over 16. Thus, the distance final is 16 over 3 negative, such that that would be, let's see, the distance final is about roughly negative 5.33 centimeters from the mirror, which means that it would be behind. So this distance here, even though it's drawn pretty poorly, and that would be repeating, but we'll put sig figs on it, which would be, it would bring us down to, in this case, the problem gave us 2, so we would say 5.3 centimeters behind the mirror. Okay, hopefully you were able to find that, so hopefully that's not too hard to imagine. The math gets really wonky, especially if you're just using algebra and the signs and everything. Like, how do you know when to use a right sign? You just need to know that the virtual image is going to be behind, thus the focal point, we need to set that negative. Man, there's a lot of chalk built into this eraser. I'm not used to using chalkboards, but I thought I'd use it just for the fun of it. Okay, now what is the image's magnification? Okay, we found that it was 5.3 centimeters behind the mirror, and we showed virtuality. Okay, what's the magnification? Well, to understand magnification, what we have to do is understand that the magnification of the image is equal to the negative distance of the virtual image with respect to the mirror over that initial distance. Okay, so we just need to plug and chug here, honestly, and we're going to find that it's going to be negative 5.3, repeating, over the distance initially, which is 16 centimeters, and thus the magnification in this case will be the magnification is going to be 0.33 repeating, or sorry, not repeating, just we'll leave it at that, 0.33, which means not only did you get an upright image, so when you view this image, it's going to not only be upright, however, the magnification is going to be shrunken. So when you look at this image, it's going to be a little shrunken portion of what it used to be. So hopefully you guys enjoyed that. If you did, please drop a like, comment, and subscribe. I would greatly appreciate it, and I hope that you have a wonderful day. Bye-bye.